Okay. Okay, so we have SDC, which is 16 GB, okay? So let's make a partition out of that. So to do the partition, you type fdisk, then type dev slash SDC, okay? Because this is where this SDC is sitting in. Okay, I hit enter, and then let me push menu here, and then we are creating a partition. So there would be an N to add a new partition. So I'm creating new. I hit enter, and then it's telling me which partition you want to do. You want to type P for primary partition, and it's asking for the partition number. You just type 1, and then it's asking what is the first cylinder. You just hit enter for default, and then hit enter again for default. Okay. Okay, I did a mistake here, so let me come back in here again. Okay, I'm gonna create a new partition, and I'm creating a primary partition, and then it's asking me for the partition number. I'm just giving you 1, and it's asking me how many cylinders you want to see. So I'm not worried about that. I'm just hitting enter, and then now it's telling me what is the size you want to create. So I want to create uh, U2 plus 8 GB. Okay, so the entire disk size is 16 GB, but we're not using the entire size here. Okay, so this is a 16 GB drive. Okay. Okay, so that's SDB. And then I'm creating a 8 GB partition. So let me hit enter, and then let me go look at the partition size, and you see there are many blocks. That means it equals to 8 GB. Okay, then I type W to write and exit and hit enter. Okay, so what happened now is the disk is been created here. So if I type LSBLK, okay, you see here that the size is SDC1 is there, and then it's showing a 7.5. So a little bit size of the disk has been reserved here. Okay, give me one moment. Okay, somebody said recording might be stopped here. Let me check. Yeah, recording is there. I'm recording it locally. Okay. Okay, good. So let's see here. So what happened so far? I created a partition here. So what is the size of a partition? I just created a size of a partition which is 8 GB. Okay. So this size is it's a 8 GB partition. Okay. So what is the name of the partition? Dev slash SDC1. Okay. And let's see here. Okay, and then the next command is part X -v -a. Then you type dev slash sdbc sdc, I'm sorry, and hit enter. SDC1 probably. Oh, okay, thank you. Okay, yeah. Let's see what is LSBLK showing. Okay. Now we are not done yet, so let's make a partition here. Okay. What is the command to make the ext4 partition? mkfs. I'm sorry, file system. Excuse me. .ext4 slash dev slash sdc1. Okay, so it did its magic, and then let's see LSBLK. Okay, so but still showing this here. I don't know why. But over here it showed 4 GB, 7 GB. Okay, whatever. You get the idea. We created a partition which is 8 GB. Okay, and let's mount it. mkdir slash okay, I'm going to mount slash dev slash sdc1. I'm going to mount it to partition 1. Okay, so the disk sdc1 is being used for the folder partition here. So let's go in there and make some files. Cd partition. Okay, it's nothing in there. Those are the default files that comes in. I'm gonna remove that, and then let me do ls. Still nothing in there, right? Okay, give me 1 second here. Just making sure recording is there. So I'm going to create about 100 files here. Touch F or so there are about 100 files in here, right? Now I have a need. I have a need to extend the partition here, because there is a time has come that 8 GB is not there. So 8 GB is full. So how am I going to do that? It's pretty simple here. What you have to do is you just have to simply unmount it. Okay, umount slash dev slash sdc1. Okay, it says device is busy. It's busy because we are inside that drive. We are inside that folder. So I'm going to get out of that and run that command again. And if I type dffnh, it's not there anymore. Okay. All right. So now before that, let me capture all the so I'm not going to show you the fdisk part. So now I'm going to unmount it. Unmount slash dev slash sdc1. Okay, so we have just done that. FDC1 is unmounted. So you type dffnh, you see the partition, I mean the disk is not mounted here. Okay, so let's see here. So what you have to do is you have to delete the partition and extend it again. Okay, so you go to fdisk/dev/sd sdc. Okay, and then I'm going to push M. Okay, so what happened here is we are looking at the menu here. I'm going to push P, and it says here like SDC1 is about 8 gigabytes. Okay, so what I'm going to do is I'm going to delete the partition and create a new one. Okay, so what is the option to delete the partition? It's simply D and enter, and it says selected partition 1. Okay, let me just push P, so the partition is gone. Partition SDC1 is gone. So I'm going to create a new partition, create N, and hit enter. And then I'm going to create primary, P, enter. And then I'm going to, it's a partition number is 1. Okay, and it's asking me what are the default cylinders. I'm going to just hit enter here. Now I'm going to extend this size to 12. How much? 12 GB. Let me just type 12 GB. 12G, I think. Did I type GB last time? That's why I messed up, I suppose. Okay. SDC1 is okay, give me 1 second. What? I cannot hear you. Yeah, but it's saying only 10. It's not saying much here. Okay, give me, am I missing a step here? Okay, partition N plus 4G. Okay, so I didn't type plus 4G, right? So let me just delete this. Okay, okay, so there is no partition. I'm gonna type M here so that we have a menu here. I'm gonna create N and hit enter. And then which partition you want it to, primary, right? So you just type P and hit enter, okay? And then it's asking for the partition number. I'm gonna type 1 and hit enter. And it's telling me how many cylinders it wants. I'm not saying anything, so I hit enter here. Now, here I type 12G, okay? And hit enter. Let me see. Okay, now it makes sense. Okay, so what I'm going to do is I'm going to write and exit out of here. Okay, now be careful here because the data is still on the disk here. So we're not going to run the regular command here. We're going to run the command that will extend the partition here. Okay. So there is one command here. You check the file system here. So what is the file system you have? To check it, you type E2 FSCK. Okay. File system check -F, and then you type dev slash SDC1. Okay, so what it's doing here is It's checking for inodes, blocks, and size, checking the directory structure, lost and found, not found, create one. We don't want that. Okay. And then we have this. We have the disk check here. It checked the disk here. So the disk is not ready yet. Okay. So the disk is not ready yet. But there is a command you have to type. Resize, RESIZE. Okay, resize to FS. Okay. This command, what it's saying is it's resizing the file system. And which file system? This file system, dep/sdc1. Okay. And you hit enter. Okay, resize. Please run FS2. We did that, right? Resize. SDC1. Okay, maybe I need to create this. Okay. Now once we remount it, our data should be there. Okay, let's take a look. Oh. I'm doing it backwards. Okay. So what we have done is we have safely extended the partition here. Okay, it's a little bit different here, but when you are extending the partition, very careful. What I normally do is I usually write it down on a piece of paper, what you have before and what you're doing. That way you don't have any confusion here. Okay. All right. So let's see here. Oh man. Okay, so we added another 4 GB to it. Okay, so the size is now 12 GB. Okay. Okay. Is it clear so far? Any questions? All right, let me just copy the commands here we used. Okay, so we unmounted it, and then we did fdisk, use fdisk command to delete partition. Okay, create new partition. Okay. All right. So we created a new partition. Then write an exit. Okay. Once you write an exit, then you're running this command here. E2FSCK. So what this stands for is extend file system. Check. Okay. Once you have done that, then the next command is you're actually doing the resize. Resize to FS. Okay. So you resizes mount / partition, and then you go into CD partition. Your data should be there. Yes, sir. Yeah, this one. You're right. Yeah. So if it's already hard coded in FS tab, all you have to type is mount-a. It will reload what's in the. It will reload what's in the. Uh, it's in the what's in the FS tab here, right? Everybody knows what etc FS tab is. Okay. So if you have inputted the information here, it's hard coded. So remember, I told you either you could do it with SDB dev slash the either you could do it with path or you could do it with UUID. Okay. Okay. Let's see here. Yes, but the UUID changes too. UUID changes uh, when you are extending the inodes for sure. Oh, I should have captured. I should have captured if the UUID has changed or not. I suppose that would be your assignment to find out next 2 weeks. Okay, put it in the chat when you find out if the UUID is changing when you resizing it. I'm pretty sure it does changes. Or if the data is going to be there, it may not change then. I'm thinking it won't change, but you let me know next week. Like orange. Okay. I could barely hear you. No. Anybody else is having problem? Okay, I could hear the person who just said something, but I cannot hear somebody's asking a question. You guys could hear me clearly, right? Okay. Okay, good. Okay, this looks better here. Yeah, I could hear you now. What was the question? Yeah, what is doing is checking the integrity. Checking the integrity. So it's I mean in nutshell it's just checking the hard drive is able to resize or not. But what it's actually doing is it's checking the blocks on the partition and see if partition is resizable. Uh, it's I suppose what it's doing here is it's checking and then at the same time also looking for any missing things that it want to make it as a new disk. Okay, so new disk has some default files. I think we got a message here, right? It's if you want to add a lost and found folder, which is a default folder. Where is this at? Uh, okay, let's not worry about that. Yes, yeah. So, but you remember you have to run this command. Yeah, I tried to run this command. It gave me error. You have to run this command. So extend to file system check. What it's doing is FSCK stands for file system check. It's checking the file system if it's extendable or not. Okay, it extends the integrity, and what this one does is it resizes the file system, resize to FS. Okay, all right, I'm gonna pause here, and then anybody has any questions so far? So there is another concept here. We are using fdisk so far, right? There is another concept called gdisk. Okay, so what is gdisk? Gdisk is it's used to create GPT. Gdisk. Okay, so what is GPT? GPT is let's search on the internet. What is GPT? Okay, let's see here. GPT. Okay, so GPT stands for uh, GUID. Okay, so GPT stands for GUID partition table. Okay, so what is GUID? GUID. Okay, so UUID. Okay, is an acronym for okay. GUID is globally unique identifier, which is UUID. Okay, universal unique identifier. Okay, we talked about this last week. So partition table. Okay, so why are we talking about this? Okay, so what is the difference here? So the difference is, let's see here. I thought I saw something here. What is GPT and MBR? So the first one we used fdisk. the F disk we use, it's using MBR. It's using the master boot record uh, format, but GUID is using a GPT. Okay, let's see here. GPT is better than MBR if your disk is larger than 2 terabytes, since you can only use 2 terabytes of space from um 512 bytes. Sector hard disk is, if you initialize it to MBR, you would be better format. Your disk is to GPT is larger than 2 terabytes. Okay, so if you have a simple disk which is less than 2 terabytes, then what you could do is you could use F disk. But if it's more than 2 terabytes, then you could use G disk. Okay, so usually the very first operating system drive uses F disk because those drives are not that big. Those are not operating system drives are not very big. F disk. All right, I should define F disk too, right? Okay, what does F disk stands for? File system. Uh, Command line. No. Okay, so F disk stands for fixed disk drives. Okay. You have to have a bootable partition. So you have to either the real bootable partition is MBR. This is what we talked about, master boot record. You have to have like a one small place that has a partition in partition to boot off of. It is a unique bootable instructions that has the bootloader, and from there it's right here on the it says chapter 5 here, master boot record. This little sector, it has a instructions here what to do next. These are all the series of commands and chain reaction that is happening that makes the system to come up. So when you install an operating system on an external drive, then it probably end up doing the F disk. No, bootable. File system means if you have like an external hard drive, if it's not bootable, then it's just a file system. So you could use G disk on it. Okay. The moment you want a bootable drive so that the operating system boots off of it, then it has to be F disk. Okay, so let's see here. Okay, so the G disk is not installed here. So I'm going to install it from the internet, but ignore what I'm going to do in next steps here, okay? Because it's like jumping ahead of some networking things we're going to do later. So right now I'm not onto internet, right? Even though I have an IP, if I ping apple.com, I'm not on internet, okay? Let me shut it down. Okay, I'm going to add NAT here so that I could go into internet here. Okay, enable network adapter NAT. NAT stands for Network Attached Translator. By the way, have you guys tried more than two NIC cards for NIC bonding? I tried more than two, and then all of them are working. So you could try more than one for NIC bonding. Okay. Okay. So anyway, G disk and F disk are both available in Red Hat 7. Okay, Red Hat 7 automatically supports it. You don't have to download it. Okay. All right. So let me download. Okay. Okay. Let's see here. Okay. Huh. We don't have internet connection yet. Let's see what's going on. Network. Okay. All right. Hmm. Okay. Hmm. That's a good observation here. Let me give it one more chance and then I'll change it. Okay. So, Okay, so the IP has changed. Hmm. Okay, it still won't go online here. So what I'm going to do is I'm going to start another box. Okay, so let me start this one. Network. See, this one has network and NAT and it's working. I cannot hear you. I hear you, but very weak. A network? Yeah, so it has this one selected, right? Yeah, it's the same thing selected. One of them is allow all. Mm. This one has deny. Yeah, we have a nick boarding. Well, but oh no, not this one here. So this thing is not changing. This one is set to allow all. Let's see, it's not gonna work. So let me start this one here. Okay. Yeah, we have. Okay. Okay, so I'm gonna go install gdisk. Yum install gdisk. Okay, on 7 it's already there, but on 6 it's not there, so we have to install it. All right, don't worry about this, what I'm doing now, but we'll go more into Yum repository later on. Okay. Okay. So you'll be surprised that gdisk work exactly like fdisk. All right. There's barely any difference here. Maybe just the difference of the code. So how are we gonna run the gdisk commands? Simple. Gdisk /def /sdb and hit enter. Okay. And oh, okay, it's a good thing. It's automatically checking if MBR is already on it, and it's checking for other partitions here. BSD, APM, all these are Unix flavors, and MBR. So it checked any other kind of partition are there. If not, then it's creating a gdisk. So it's creating a gdisk entry. So here, instead of M in fdisk, you have to type question to get the menu, and then same exact menu here. So we have to see if any tables are present. Type P to present. Okay, so it's nothing in there. So what I'm going to do is I'm going to do N for new, and it's asking me the same exact way the partition number. You hit enter here, and it's telling me the first disk sector. I'm going to hit enter here. Now I'm going to create a 8 GB disk. By the way, what's the size of this? Okay, the size is 8 GB. So I'm going to create 4 GB plus 4G. Okay, I'm going to hit enter, and then it's asking for the hex code. Hex code here is 8300, right? For our F disk, the hex code was 83. It's adding extra zeros here. That's all it is. Okay, so let's take a look here. I'm going to go into L and hit enter. These are the codes here. I think I talked to you about one time. What are these codes here? In Linux file system, in fdisk it's 83. Okay, in here it's saying 8300, 8400. So it's adding extra zeros here. So I want to type either 8300 or just hit enter. It will take it as 8300 as hex code. Okay, let's do P. Okay, so what it did here is it created a partition out of 8 gig of hard drive. The partition size is 4. Okay, so let's do the question here. And then I want to write an exit, type W. And then do you want to proceed? It's kind of giving you the extra warning here. Yes. So the partition is been created now. How we know? LSBLK. So you see SDB1 is there with 4 GB. Okay, BLKID. Okay, so let's see here, SDB. Okay, so the BLK ID is not there because we haven't created the partition yet. Okay, so let's create a partition here. What is the command? mkfs dot ext4 and then dev slash sdb1. Okay, I'm missing 4. Okay, so the ext partition has been created. Okay, but for in Red Hat 7, what is the command we use for creating a partition? If it's a XFS file system, if it's an XFS file system, you type in yes. Let's see here. Yeah, MK XFS for Red Hat 7. Good, thank you. Now you do BLK ID. Okay, now you see the ID is there. Okay, everything else is same here. So I'm not gonna go mounting and all that. I'm not gonna show you all that now. Create partition just like fdisk. The hex code will be default to 8300. Okay, and then the command is mkfs.ext4 / dev / sdb1. Okay, so this is for Red Hat. I'm gonna just mark it Red Hat 7. Okay, great. Okay, so now I think I forgot to show you one thing. How you could create a label for the partition here. Okay, so what you could do is you could create a label for this. So you type e label, e2 label / dev / sdb1. Okay, BLK. Okay, I think I gave you. Okay, BLKID. Okay, here what I did here is I gave this disk a name. Instead of dev / sdb1, I gave it a name as a label. Okay, I gave it a label name here. So this is going to come handy when you have one machine and there are like several different departments using the same drive but different partitions here. So you could give it a name here: accounting, finance, IT, or whatever. So why is this going to come in handy here? I'll show you how. Okay, let's go into etc vi / etc / fs tab. Okay, and hit enter. Here I'm going to make a permanent entry here. Okay, I'm going to make a permanent entry here. So how am I going to do that? Either I type the UUID or I type either all that, or I could start giving it a label name here. Okay, and where is this label is going to be on? Label is going to be on partition. It's mounted to partition, PART. Okay, and then what kind of file system here? You're going to have to look it up here, okay? ext4. I'm giving tabs. These are not spaces. It matters, yes. Normally, the good practice is copy this line here. Copy this line. Okay, one space. There is a space here, but all the other ones are tab. So what I normally do here is I go up here, right here. I copy YY, come down here, O, and then I paste it in here. Okay, so you could see I copied almost everything in here. All I have to do is just edit this information here, right? Okay. I'm going to commit it out. Okay. I'm going to save and exit. But this is a different host, so I'm going to create a mkdir space partition, partition. Okay. Okay. Now I made the entry into FS tab here. How do I mount it now? Yes, yes. Yeah, that's a true statement. But since I was already in the FS tab, I mount -A. What it's going to do is it's going to run through all the FS tab entries, and whichever one is not mounted is going to mount it for you. Okay. Now if I type dff-h, there you go. You have SDB1, which is mounted on partition here. But this time we used the command label. We used it label. Okay. All right. So sorry I missed this command. Okay, history. Okay. Okay, so the output would be Okay. Is it clear now? Is it making sense here so far? Okay, so you guys get the idea what's happening here. Okay, so let's see here. Mounting disk, mounting UUID. Alright, I will might as well put in here using a label, okay? Mounting disk, FS tab, mounting using this, and let's see here. Okay, let's see here. U mount. U mount. Okay, so you want label equal. Okay. Okay, so okay. Unmount hyphen L and the label name. U mount. Oh yeah, thank you. Invalid L. Let me put a small L in there. U mount hyphen A hyphen T V H verbose I N D O lazy mount detach the file system hyphen L. How about what? You should be able to do unmount using label equals umount hyphen L ZMPT1. Okay. He says and umount hyphen doesn't work. This one hyphen F. The whole thing like this. Mm, L. Let me try small L. Not found. Oh, okay. That's silly thing. LABEL. So I have to remove this now. Capital L. Quotes. Okay, I got it. Is it going to work now? No. -L. No, unmount. The only unmount you could do is, but anyway, let's get out of this. So you get the idea, and okay, label. I just can't spell it. Okay, so okay, okay, good. So let's see here. We are here. So we could do mount using UUID, using label. We looked into extending inodes, extending partition, gdisk. Okay, create partition just like fdisk. Hex code will be 8300, mk2fs, and it supports the partition more than 2 GB. Okay, 2 terabytes. Okay, I think we're good here. So I'm gonna bring my old host back. Here, I think it has 3 drives in there, right? 1, 2, 3. I'm gonna add one more in here, okay? This 3, disk 4. Okay, I'm going to start off a little bit on logical volume, LVM. Guys, this is very, very important. Any interview question, they will ask you about LVM, and you must be prepared for this. I would say practice this about 200 times and get creative, delete, create, destroy. The more you practice, the more you break your system, the better it's going to be for you, okay? Because right now, even now, I'm a little surprised during May, the Linux job market is very, very hot still because the cloud is exploding and there is a lot of demand for Linux guys. Once you get a Linux job, then you could explore a lot of other avenues, cloud, this and that. Okay, that's right. We made it DHCP. Okay, so we have three drives here, right? I'm going to set this up here. I'm going to remove the partitions from all three here, okay? SDC. Oh. Hmm. It says SDB is there, right? So, okay. So I have to unmount it first. You know what? There is one more command, umount -a. Anything which is not system related, like this two, is going to unmount this. Okay. Mount -a is you unmount it, but umount -a, it unmounts itself. Okay. Some cases useful busy. Okay. It unmounted these two drives here because these are the extra drives. But we got the message here that this is busy. Of course, this is busy because we are in root partition. So it won't unmount that, but it gave you an error. So let me destroy this. Okay. We are seeing two partitions here, but it says the partition is not there. Did we use something else to create a partition? Yeah, but I unmounted it. So if I unmounted it, it should delete it, right? Oh, give me 1 second here. Okay, MK. It is a reboot or something, right? Okay. It happened to me while on the call. Oh, okay. You were practicing. Okay. Okay, now it's gone. Okay, so what I'm gonna do now is we have about 10 minutes. So before I go into LVM, I'm gonna create a swap. Okay, let's study a little bit about swap. Let's think what swap is. Okay, so here you have like a RAM in your system, right? But in Linux, it also has. So this system has about 1 gigabytes of RAM and 1.6 gigabyte of swap, please. Swap is usually a part of a swap is usually a part of a physical hard drive, which acts as a a volatile memory. So if this thing runs out, it needs like the processors which are not being used, or processors which are passive and which are just sitting around and not being used. It moves those processes to swap. So it doesn't kill. If the memory is up, it's actually extending the size of the memory here, but it's extending it to the physical hard disk. Okay. So right now the swap is being showed as 1.6 gigabyte. So how do we know it's the swap? We type df-h, and in here you see. Okay, dev. Okay, okay. So in here you see volume group 14 GB and all this here. Where is the swap? Okay. So what happened here is the system created a boot folder root, and then I'm sorry, it created a root and it created a boot folder. Okay, and at the same time it also created another folder, another space called swap, and this is being used as a memory here. Okay, and so the size of the swap is 1.6 GB. I think it's 2 GB. Okay, LSBLK. Okay, right here. It's a SDA drive. SDA is which is our very primary drive here. Okay. So which one is SDA here? I think I showed you one time. You go into SDA. this is our SDA. You have to have at least one drive for the system to install the partition, MBR, and all that. Okay, this is where it's all coming from. Okay, so SDA, when you are installing using the CD, it created a partition one about 500 GB, and then it put the boot files in there, and then it created another partition with the rest of the disk size, and in that it created a logical volume, logical partition, which is used for root, and it created another one, logical volume, and it's being used for swap. Okay, what is swap? It's a memory used from hard disk. Okay, so let's see what is the definition here. What is okay? A swap file or a swap space is a space on a hard disk used as a virtual memory extension of the computer's real memory. Okay, this is good. This is a good example. Okay, so the size could be your size real memory. If your real memory is if the real memory is 1 gig and the swap memory is 1.6 gig, the total memory available is 2.6 GB. Okay, good. So when we type df-h, or the command for a the command for swap to check the memory is free. You could type free and then it doesn't give you human readable information. You type free-h. It gives you some information that you could read. Okay. Let me just clear this. Okay. So over here it type mem, means this is a physical memory. Okay. We all seen the memory, right? Computer memory. What does it look like? Okay, this is what a memory chips looks like. Okay, you put in the memory here. Okay, but the swap is not that. Swap is actually a little partition on the physical hard drive. Okay, so it all should be good enough here. But swap, the system uses the swap memory to keep the processes not being used at the moment. System uses the swap memory when the real memory is full, but moves the processes which are not active, okay, to swap. Okay. All right, guys. You have to tell me, is it making sense now? Let me know, because What I've seen is usually it's reserved for the system automatically. If you have like 100 things running simultaneously in real world scenario, which is a real. So out of that, 50 processes are being there, but it's just sitting around in the memory and doing nothing. And a new process came in. So what it does it moves the old processes to the swap and then start using the memory here. Okay. So at this moment, our system is using uh, since it has a lot of memory here, right? It still have about 700 megabits out of 1 gig of RAM to still to be used here. When all this is used up, what it does it moves old processes to swap memory here. Slowly it moves here, but it will still show you that the memory is full. So swap is just a safety net, okay? It just is just used as safety net for the real memory. Yeah, it will slow down, and actually this systems has a monitoring enabled on it. So stupid little things are monitored on in the big environment, like how much it will generate a alert. There is a monitoring tools that are out there, like Tivoli, and there is a bunch of other ones. I'm not heavily involved in those situations yet, but as an admin, say for example, the memory is full and the swap is about 50%, then you will get a ticket that says, okay, the the swap memory is full, so you have to take a look here. So we'll talk more about it, how to determine which process is taking how much memory when we're doing some troubleshooting at the end of the class. Okay. But right now, this is a fairly good example of what a swap memory is. And then I'm going to tomorrow we're going to create a partition, and then we're going to use that partition as a swap memory. Okay. So things are going to get interesting. Obviously it takes the load off, and then when usually in a database this is usually 16 GB, okay, and they are keep monitoring it, and then you will get a ticket when the swap is 25% and the memory is full. So you have to start working with the database team or the other application teams and determine if the process is being used by the root, which will be you guys, which will be us, or it will be used by a database or other application. I will show you later on how to determine whose problem is that. Okay. But for now, this is the good information we have here. Let me see if I could find a graphic for. Okay, yeah, this looks good here. So this is a physical memory, and then this is a hard drive, and it's using a little part of a hard drive as a memory. So it's 2 GB, and 2 GB RAM equals 4 GB swap. So memory amount is in GB, and then okay, this is 2 GB, and then how much is this hard drive? So you get the idea, right? It's actually using the little partition on the physical drive. Okay. All right, good. I'm going to stop here and we'll pick up tomorrow here. If everybody could join on time, and then we'll use the full 2 hours tomorrow, LVM. Okay, so as soon as the recording is ready, then I will update it and then I'll put it in the chat. Okay. All right. Thanks for joining, guys.